Okay, we're going to go ahead and start, and we're going to do the second orthographic projection, number 2. But before we get started, I want to point out a couple things. One, to save time, I went ahead and actually drafted up a blank drawing sheet. I talked about this before in class, but it's also a common practice that's used in industry. Typically an architect or mechanical engineering company or a manufacturer will go ahead and draw up what their standard drawing sheets are going to look like. In this case, it's an A sheet. Well, I went ahead and did that. And I put my name, Richard Platt, and I put number, and I left it kind of blank here, and I went ahead and set the scale at 1.5. So to save time and continuing and to not having to redraft this each time, I went ahead and drew this up, and then I took it to my little inkjet printer, and I copied it, I scanned it, and I copied it, and I did this. Well, the first time I did it kind of upside down orientation, and I didn't get this side of the drawing, so I went ahead and flipped it around, and I went ahead and copied again, and I got this, which is what you see here, which is also what you see taped down. Everything turned out pretty good, except it did not put in the line on the other side, and I think that's just an anomaly that's typically on a typical inkjet standard printer you'd buy at Walmart or Best Buy or whatever. But anyway, as you can see, I just have to come back in and draw this side in. Well, I went ahead and I taped down the drawing, and we're going to go ahead and do that. We're going to draw in just that one line to the left-hand side of the sheet. And again, it saves us a lot of time because we've already got all this stuff here drawn in. So what I'm going to do now is go ahead and draft that piece in. I'm going to come in here and I'll make me a mark at 1/4 inch here. Then I'll take my scale or ruler or whatever I have, and I'll come up here and I'll make myself a mark there. Okay, so now that I got that in, I'm going to go ahead and take my 306090 that we actually produced on our laser engraver. We designed it up in Adobe Illustrator, and we came in and we lasered this out, and we have us a drafting tool, actually a quite nice one. So I'm going to go ahead and I'm going to draw this line in. Now, as you notice, I'm not using a standard pen that you would buy, say at like you'd buy like a 7/0 pen or 5mm pen. I'm actually using a drafting pencil. These drafting pencils, this one's made by Stadler Mars. I think Alvin makes one. There's probably some other vendors out there that make them. These are actually really nice pencils. I used to use these back when I was at Johnson Space Center at NASA, and you basically put a lead in there like that. Now, I went ahead and purchased a sharpener for this, and in the industry, you'll also see a lot of these kind of sharpeners like this where you put the pencil in, and you go ahead and sharpen it. You have to sometimes let it out a little bit, and then you put it in here and you sharpen it. And so you can kind of hear it in there and just grinding away and getting this to a really, really nice point. You can see it. Now, to get the graphite that's off it from the sharpening process, you just come in here and kind of tip that edge, and you get a really nice point that comes off on the pencil. These are great. They last forever as long as you take care of them. And they produce very nice solid lines. So I'm going to go ahead and extend this one line over from the bottom. It didn't quite get it. I guess there was about a 1/2 inch border on the inkjet printer that didn't get that. I'll tighten up that lead just a little bit. Come back up here to the top, and I'll extend this line here over to this edge, and now we have completed our border sheet. Well, that's a whole lot faster than going out and redrafting it. I'll make that line just a little heavier there, so kind of finish up that one area right there. So that looks pretty good. All right. Now, again, it's like with anything. We divide and conquer so we can have our top, our front, our right view, and our isometric view equally spaced out. So we're going to take this and we're going to divide this in 2, which is 5.5, as you see here. I'll make me a mark there on my paper, a light mark, because I'm going to erase that later. I'll come over here and I'll come down to 4.25, which is halfway, if I look at the paper, horizontal. Take my T-square, put it on here. I'll go to that first mark and I'll draw myself a very light line. Not a heavy line, but a light line, as you see right there. You probably can't see it on the camera, but trust me, it's a very light line. So we'll take this one right here. We'll draw us a light line that way. Now that we've got that light line, we've not done yet in laying out the quadrants. So we've got our top, our front, our right, and our isometric. We're going to come and put our scale on the 1-inch mark right down that center line. Make a mark here and a mark there. And what that does is it puts us on one side of the part either way. So I'll take my 3060 and my T-square, and I'll put that flush on the edge, so basically it's perpendicular. I'll draw myself a light line going across the drawing. And on this one, what I'm going to do is I'm going to draw a light line up to about right there, and then I'm going to come over here and make me a mark, because I'm going to use that as an anchor point later for my isometric. So I've got that done. Now what I'm going to do, I'll move this away, and I'll come down here and I'll make my line here at a 1, and I'll put a mark there at the 2 and a mark there at the 0. Take my t-square, come over here, and I'll come from my left to my right, basically stopping right there, and then I'll come over and make a mark in the ISO view. Then I'll take my t-square, come down this way a little bit. And on this one, I'm just going to go all the way across. I'm going to go from about the edge here all the way over to about right there. That's plenty long. So now what I've done is, by doing these lines an inch off and an inch below, you know, the horizontal line, I've created the bottom face of the top view in the part. I've created the top face, or the top edge, of the the front view of the part, as well as the right-hand side of the part, same up here, the right-hand side there. And I've created the left and the top here on the front view. So that's really nice. So now, essentially, we're going to make this particular drawing that you see here. We're going to draw this guy up, front views right, and all that kind of stuff, and we're going to create that missing view that's up here on the top. Actually, that was drawn incorrectly, so we're going to fix that. So now what I'm going to do is I'm going to go ahead and I'm going to knowing that I'm working in half scale, I know that instead of 5 inches across, it's going to be 2.5. So I'll make myself a mark here, just right there. Take my t-square, excuse me, and my nice 30, 60, 90 that we lasered out and saved ourselves a lot of money. And I did this with just standard acrylic. And I'll come up here and I'll draw a line there. So now I've got 3 sides of the front, of the top and the front view done. So we know that the part is 1.5 inches across. So what we're going to do is we're going to divide that by 0.75. So we'll come over and make that 0.75. So we're going to make 3/4 of a mark there. And we'll come up to our 30, 60 as we see right here. And we'll put that on there, and we'll come up here. Now, we know that the height of the part says it's 2.5. Well, 2.5 is too big for this sheet of paper, so we got to go half scale. So if it's 2.5, oh, let's finish this here first. We know 3/4 on this top view because that distance is 3/4. We know it's going to be 3/4 here because remember it's half scale, so it'd be 1.5 divided by 2, half scale. All right, so now come across here, and we're going to take our line and draw that across the top view there. Nice, okay. Now, we know that the height of the part we said was 2.5, so half of 2.5 is what? It's 1.25, Mr. Platt. All right, so we come down here and find 1.25. There it is. Okay, we'll take that mark across here, 1.25. There, and we'll go ahead and make an extension line all across here. So we may come back and use that extension line as part of our dimension string. Now, we know that the part is 5 inches. We know that half of 5 inches is 2.5. Well, half of 2.5 is 1.25, which would divide that 2.5 into 1.25. So we'll come up here and we'll find 1.25, make ourselves a mark here. I'm going to take that up to the top. All right, so we're going to take this up to the top. We're going to take our 30, 60, 90 perpendicular to our t-square, which is grabbing the edge of the table, and we're going to go up. So we're going to come up here, just like that. Make us a light line up there. Now, we know that the part's kind of got like this stair-step look to it. If you look here, it's got this stair-step right there. So we got to make that on this top view here. So that's pretty simple. So half of 0.75 or 3/4 is going to be 3/8. So half of 3/4 will be 3/8. So we go 1/8, 2/8, 3/8, and that will dissect or bisect that line right down the middle, or that part right down the middle. We know we don't have to go all the way over, so we're just going to go over to this point here. Now notice I made it kind of heavy line there, because I know that's going to become the object line of the actual part. The object line, remember, is always the outer perimeter of the part in a given view. Okay, so we knew that that was 3/8 of an inch, or 0.375, so we're going to come over here and we're going to do the same thing. We're going to mark off 1/8, 2/8, 3/8, make that mark. Now over time, as you start drafting and designing, whether you're working in metric or you're working in imperial or English units, whatever you want to call them, you're going to start memorizing the decimal and fractional equivalents. You're also going to start converting in your mind automatically, you know, what is 1/4 of an inch in, say, metric. It's going to be 6.35 millimeters. So you're going to start making those kind of equations in your mind. It's always good to have a fractional, decimal, and millimeter chart in your engineering notebook, so that way you can quickly make those calculations, as opposed to, or actually just see those instead of having to make those calculations. Saves you an awful lot of time. All right, looks like we've got our part in the top, in the front, and the right view drawn. Let's come back and let's heavy up the object lines so that we will know specifically what this guy looks like. So I'm going to come across here at the top, make that real heavy. Just start stepping down to this view like right there. Make that guy heavy, as you can see. Notice how I only go to this side of the part because I don't need to go that far on the other side. So we'll make that heavy. And you start seeing those object lines starting to appear. Now we'll come down to the front view and we're going to go all the way across. We're going to do this one line here, heavy. We'll go to the edge of the object line. We'll come across over here to this side. We'll make that heavy. If you need to go back and forth after you made your first bar, now you can do that. I'm going to come down here to this guy right here. Do the same thing. Make it heavy. And same on the other side for the right view. Okay, it looks good. You see it darkening up a little bit. Now we'll take our 30, 60, 90 and we'll work left to right. So we'll come over here on the left side of the top and the front view. We'll line up the lines, and the old saying, connect the dots. Actually, we're going to be connecting the lines, or the object lines. Okay, see that's drawn in? We'll come up here and do the same up here. We'll draw that guy in. Looks pretty good. Now we're going to come across here and we'll line up our center lines, or actually our bisector lines of the part. We're going to come down here. We're going to draw that guy in real heavy there. Looks pretty good. Come over here and do the same thing. We'll draw this guy in heavy as well. All right, moving across. We're going to come to this guy right there. We're going to draw that guy heavy in. So we'll go ahead and do that too. All right. Now I'm leaving a lot of space over here so I can use my eraser shield to erase all that and clean up my extraneous lines I don't need. Now I'm going to clean up one before I start on the isometric. So we'll go ahead and draw the left line on the right side of the part. Come over here, do the same. Oh, got to get the one in the middle. Forgot that one. Okay, line that up. Now as you draft and you start doing this more and more, you're going to get fast and you're going to get really good at it. It's kind of like learning how to swim or ride a bicycle or hit a baseball. You know, the more you do it, the better you get. It's like, you know, maybe playing basketball. The more you play, the better you get. It's no different. Okay, so now you can see our top, our front, and our right view. Now we're going to go back with our white eraser. We use white because we don't want to dig into our paper, and it's much more efficient to use a white eraser in cleaning up some lines. So as you notice here, I'm basically taking out those two center lines. Now, I have my trusty old good drafting brush so I can clean off all those erasure marks. When I do that, I don't put any dark marks on my hands or on myself. And occasionally, if you've been drafting for a while, like say a couple hours, you want to go wash your hands and get any kind of graphite that's built up on it. It looks pretty good. Now I'm going to go ahead and clean up this one little spot right here because I don't need that. I'm going to take him out later anyway. All right. So again, drafting brush here. Now I went ahead and purchased. I got this set actually at Michael's. It's you can get them at Hobby Lobby or Staples or Office Depot, wherever you're going to go. I think you might can find them at Walmart if you look hard enough. I'll use my eraser shield, which blocks my good lines and not gets rid of my blocks and protects my good lines and allows me to come back and erase the lines I don't need. And again, brush that guy off. Okay, it looks pretty good. Now I like the fun part. The fun part to me is it's not just doing the top, front, and right view. It's always the ISO. Because the ISO gives us the opportunity to actually draw in 3D. This is where the draftsman becomes the artist, if you may. The artist and the draftsman combine right here. People say, well, artists, you know, draftsmen aren't artists. Well, I kind of disagree with that. I believe artists are good draftsmen. Michelangelo was considered one of the greatest draftsmen of all time. You know, he did some pretty good work if you ask me. I mean, he drafted St. Peter's Basilica, one of the most important buildings in history. And he came up with that. So as you notice here, I went ahead and did the vertical line on the 30-60. I've got it oriented going the 30-degree angle going a long way. So I'm going to come down here, draw this line in here like that. So I've got two of my lines in. Now we know our part is divided by 2, so it's 5 divided by 2, so that's going to be 2.5. So I'll come down here, I'll make my mark at 2.5. Now this is going to give me 2 lines here. I know that the height of the part is divided in 2, which is 2.5, so it's going to be 1.25, and that's going to give me 2 lines. Let me show you how. So I've got that in there, The first thing I'm going to do is I'm going to go ahead and flip this guy. Oh, actually, no, I'm not. I'm going to come over here and draw this first line in like right here where I made this mark. As you see, just come down like so. You can go as far as you want, but I'm not going to go that far. Then I'm going to just move my 30/60 down to that last mark there. I'll make me a light line coming up here. Then I'll do the flip where I flip the drafting tool over, and now I'll draw the opposite angle. So I'll come over here. I'll draft this line out there. Okay. I'll come back up here and I'll put this line in as well at the top. So we know that the part is 1.5 inches thick. So 1/2 inch is 0.75. So we'll go ahead and use our scale. We'll find 3/4 inch, 0.75. We'll make a mark. Come down here, do the same thing. 3/4 inch, we'll make a mark. I'm going to go ahead and cheat. I'm going to come over 1/8, 2/8, 3/8. I'm going to divide that into 3. I'm going to come back up here, and I actually don't have to do that up there. I'll just leave it like that. But I do know that 2.5 divided by 2, because I got to do this face there, is going to be 1 1/4. So I'll come up here to 1.25. I'll make a mark right about there, and grab my 30/60, and we'll start having some fun here. So I'm going to come across, making sure this guy's flush, and I'll make the line up this way, and I'll come over here to this point. I'm going to have to kind of lift this up. It's not a, my T-square is one we also made too, so I got to kind of work with what I got. So I'll come over here and I'll make a line up here like this. So I got that in there. Now I know that the part, I probably should have done this, but I'll go ahead and do this now anyway. I'm going to draw this line all the way down to here. I'll flip this, bring it over. I'll lightly draw from here to, and then I go heavy right there, okay? Then I'll take and flip it back over, and I'll come up to this part right there, go up that way, and to save time, I'll just go back across here. Oops, I got to flip it. Actually, wait a minute, let me get this one line right here. You know the old saying, connect the dots, so I got to connect these dots here. Now you're starting to see the part kind of appears coming in 3D. So what I'm going to do now is kind of move over here. So I see this from this side, and I'll come back right there, and I'll draw me a light line there. Now I'll flip it one more time, and I've got some vertices I can see. And my part is actually coming into view, which I find exciting. Yeah, it doesn't take much to excite Mr. Platt, but 3D does excite me. Whether it's manually drawn or using an awesome software product like SolidWorks, or using you know, something like 3D Studio Max, 3D's 3D, and it's always cool and it's always fun to draw with. But being able to do it with the tools that have been used for thousands of years, to me, that's just as equally and exciting and fun. And everybody says, Mr. Platt, what was the most powerful thing ever made? And I'll sit there and listen to them for a while, and I hear like, oh, you know, nuclear aircraft carriers, I'll hear submarines, I'll hear bombers, and, you know, nuclear power plants. And then I'll just kind of laugh, and I'll say, well, the most powerful things ever made was what I got in my hands right now. Because if we didn't have these drafting tools, we wouldn't have nuclear aircraft carriers, we wouldn't have nuclear submarines, we wouldn't have, you know, fighter jets and space shuttles and all that kind of stuff. CAD has not been around that long. Granted, it's amazing. It's what I made a career on, using CAD, but these drafting tools are what we built a civilization on. These drafting tools are what we built great buildings with, like the Empire State Building, the pyramids. We use it to make the Panama Canal, the Suez Canal. We used it to make some of the great engineering marvels of the world. Henry Ford used these drafting tools to come out and design the Model T, the car that changed the world. I mean, everything great originally that we've made in this world is usually started with these little tools we have here. So these three tools, the ruler, the T-square, the 30, 60, 90, to me are the most powerful tools in the world. Combined with the good old human imagination, there's no telling what we can come up with. And we've come up with some pretty amazing things. So I think these are the most powerful things in the world. These little tools. Because with a man's mind and a little education and these tools, we can make a nation, we can make a civilization, we can make great things that can help this world and protect this world. All right, that's how we got to the moon, in fact. All right, so we got this over here. We've got that drawn in, and there our 3D part. Now, this is when we need to come back and clean it up. But as you can see here, we've got our top, our fronts, our right view, and our isometric in. So now comes the part of cleaning it up, making the object lines heavier, and coming back and putting in dimensions. We probably want to clean up some of these intersections here a little bit because I was kind of at a weird angle, but we can tighten all that up. But if I'm making this part and I've got to make 2 million of them, and I've got a great drawing, it's to scale. I know that the scale down here says 1 inch equal ½ inch. So I'll measure this, and so if I'm measuring this and it says 2½ inches, I guess that's a 5-inch part when I actually make it. That's the way it works. Okay, this is good. We'll stop for now and we'll come back to this.